Written in Bone, Chapter 2, page 22. Who were you? To hear Carter Hudgens talk about finding bones is to understand what makes moments like the unearthings of JR 1225B so extraordinary. As an archaeologist, I study the material remains of the past in order to understand the histories and cultures of the past, he observed. Most of the time, archaeology concerns the recovery and analysis of artifacts. But in case of discovering a grave, I actually came face to face with the people I am studying. This, to me, is fascinating and moving. You are meeting the people of the past. They, of course, cannot talk, but they can inform us of the past through proper analysis. With the confirmation that the shaft did indeed contain human remains, the archaeologists turned to the careful and responsible excavation of their find. It was a task that would take Hudgens and team member Danny Schmidt several days and call on their specialized knowledge of human decomposition. As happens when any organism dies, the remains of a dead human being gradually decay. While a person is alive, muscles and bands of strong tissue called ligaments hold the bones in place. After death, microbes such as bacteria feed on these tissues along with the other parts of the body, causing them to decay. While this process may sound revolting to us, it's actually a fundamental step in the cycle of life. As microbes consume dead tissues to extract nutrients, the tissues are broken apart on a chemical level. They decompose into the elements they're composed of, such as carbon and nitrogen. These elements are recycled when they pass out of a microbe's system and into the soil, where they provide nutrients for other animals and plants. The tissue-dissolving action of microbes is one reason why bones are often the only remains found in graves. It also explains why those bones aren't found as close together or in as orderly a pattern as an untrained person might expect. Hudgens knew that the first step was to locate the boy's cranium, the part of the skull that encloses the brain. It's typically the highest point of the skeletal remains, Hudgens explained, because the rib cage collapses and other bones settle, as the soft tissues that surround them decompose. Typically, rib bones collapse into the chest area and settle near or on top of the vertebrae, the bones that make up a person's backbone. Because most bones settle in this manner, the skull is often a little bit closer to the surface than the rest of the skeleton. For this reason, we generally uncover the cranium completely and then progress down the body, Hudgens explained. The sharp point and edge of a metal trowel can easily nick a bone or even flake pieces from its surface. Before continuing the excavation, Hudgens and Schmidt switched from metal trowels to wood and plastic tools, which are softer than metal and less likely to cause damage. With those tools, they uncovered the top portion of the entire skeleton. Hudgens and Schmidt weren't surprised to find that the teenager's skeleton was quite fragile, even for bones 4 centuries old. This fragility is characteristic of many Jamestown skeletons, thanks to the same beige-orange, clay-filled subsoil that created the telltale post-hole soil stains, proving the team had found James Fort. Clay holds moisture longer than many other types of soil. Year after year, each time it rained on the boy's grave, water trickled down through the soil that filled the grave shaft. The rainwater drained away slowly from the dense clay-filled subsoil. In the meantime, the boy's bones absorbed some of this moisture, causing them to expand slightly. After the water drained away, the bones dried, which made them contract. This alternating cycle of expansion and contraction caused tiny flecks of bone to break off. On a scale of 1 to 10, with 10 being a skeleton in perfect condition, Hudgens estimated the condition of the boy's skeleton at only a 3 or 4. Page 25. Up on a pedestal. In theory, the team could have continued the excavation and started to remove the bones from the grave for further study. But once a skeleton has been moved, it isn't possible to recreate the burial scene with complete accuracy, especially if the bones are in poor condition. A forensic anthropologist such as Doug Owsley can gather many significant pieces of evidence by examining the bone in situ. In situ is a Latin term meaning in the exact position and place where an object is first found. For this reason, the team's focus was not on removing the bones quickly, but rather on preparing them for evaluation by Owsley. As Hudgens explained, the next step was to Pedestal the bones. In this process, we remove all the soil surrounding the bones except for that which is directly under them. The bones are left lying on a pad of soil. Pedestaling results in the highest possible visibility of the details of a skeleton as well as its position in the grave. As Hudgens pedestaled the bones, he noticed that the bones of the legs and feet were arranged in a straight line. That is, the legs were positioned close together at the knees, ankle, and feet, with the toes pointed straight up in the air. These were signs that the boy's body had been shrouded or wrapped in a cloth before it was buried. Because fabric decays more slowly than organic tissues, the shroud would have held the boy's bones close together even after his muscles and ligaments had decomposed. If a shroud had not been present to hold the bones in place, several inches of space would have eventually separated the boy's left and right legs, and the feet would have splayed, with the toes pointing onward. Page 26. The practice of shrouding was a customary manner of caring for the dead. 17th century Chesapeake colonists were not usually buried wearing their clothes. Instead, the person who had died was wrapped from head to toe in a shroud. The shroud was held in place with ropes tied above the head and below the feet or with pins. Archaeologists have noted a few exceptions to this custom. Some graves, including a few in the Starving Time Cemetery outside James Fort, include buttons and other evidence of clothing. William Kelso and Doug Owsley feel certain that these individuals were buried in fear and haste. For the settlers, the fear of catching a contagious disease by handling the clothes of an infected person would have far outweighed the benefits of touching the body to shroud it. The signs of shrouding that Hudgens observed as he pedestaled JR 1225B's bones indicated that his remains had been treated with care, according to custom. Yet Hudgens saw other signs that seemed to indicate that the body may not have been shrouded. The boy's arms weren't at his sides or in any other dignified position consistent with a 17th century shrouded English burial. His left arm lay across his body. His right arm was flung outward and upward toward his shoulder. Page 27. Did this strange position indicate that no shroud had been used to hold his limbs in place? Hudgens and Kelso didn't think so. Often, a shroud was wrapped loosely around the deceased person's chest before it was tied shut above the head. If the boy had been shrouded in that fashion, there would have been room for his arms to shift, perhaps as his body was lowered into the grave. Despite the arms being askew, the close proximity of JR 1225B's legs and feet, along with the position of the toes, provided sufficient evidence to confirm the presence of a shroud. Hudgens made another less common discovery as he continued to pedestal JR 1225B's bones. Alongside the left femur, the upper leg bone, lay a white triangular arrowhead, its point almost touching the bone. The arrowhead was a type of projectile point made and used by the Powhatan Indians who lived in the area at that time. Its presence was a very clear indication that he was wounded, stated Hudgens. Had the wound been a factor in the boy's death? Perhaps Doug Owsley could shed some light on that question, but before he tried to interpret the meaning of the arrowhead, he would have many other puzzles to consider. How old were you? A person's age at the time of death is one of the first things forensic anthropologists try to determine when they examine remains. When Owsley knelt on the soil next to JR 1225B's grave, he began his investigation by considering the length of the long bones of the skeleton's arms and legs. Long bones grow from a person's birth until the body becomes fully mature, around the time of young adulthood. For example, the femurs of the same person compared to ages 2 and 12 are likely to have doubled in length. In the case of JR 1225B, the length of the long bones quickly told Owsley that the skeleton was not that of a very young child. To obtain a more precise age estimate, he had to look closer. Long bones have two main parts: the shaft, the long straight part of the bone, and the epiphyses, the bony caps located at the end of long bones. Epiphyses remain separate from the shaft during an individual's growth years. In skeletal studies, they provide an important clue to the age at death. Until the age of about 14, a living person's epiphyses are joined to the shaft by the cartilage, the same flexible connective tissue found in the tip of the nose. Over the course of the 10 years, the epiphyses and shafts of the various long bones start to fuse together, and the cartilage between them is gradually replaced by bone. At this stage, a visible line remains at the places where the epiphyses and the shafts connect. When a female reaches the age of 14 to 18, the epiphyses begin to fuse solidly to the shafts. The line where the bones have fused together disappears as the teen ages further. The epiphyses of a male's long bones fuse 2 to 3 years later than those of a female. This fact would come into play when Ousley later considered whether the bones were those of a male or female. Inspection of the skeleton's long bones revealed that the epiphyses were still unfused, a definite sign the individual was a teenager at the time of death. Teeth also provide important clues about a person's age at death because they appear at fairly predictable times in all humans. A newborn infant usually has no visible teeth, but they are beginning to form in the jaw below the surface of the gum. By the age of 2, the child has about 20 visible teeth, often called baby teeth. Children lose their first baby teeth when they are 5 to 6 years old. At this age, they get their first set of molars, the large, flat teeth at the back of the mouth. Page 30. The second set of molars grow in about 12 years of age. A person's third and last set of molars, often called wisdom teeth, grows in at about 18 years of age. The presence or absence of these various kinds of teeth helps a forensic anthropologist estimate the person's age. JR1225B's teeth supplied additional support for Ousley's theory about the boy's age at death. The second set of molars had grown in, and the cusps, the rigid points on a tooth's surface, showed signs of wear. During colonial times, the corn and wheat used in everyday meal preparation were not ground as finely as they are in modern factories, so those people commonly ate larger pieces of grain than modern people do. Because this grittier grain was harder on the teeth, it noticeably wore them down. This type of wear is not seen in modern times. The wear on JR1225B's molars indicated that they had been used for a few years. The wisdom teeth, however, were still inside their jaw sockets, a sign that the teen was younger than 18 or 19 years old. He or she. After determining the age of a skeleton at the time of death, the next question the forensic anthropologist tries to answer is whether the person was male or female. In the case of early Jamestown, the historical record tells us that all English colonists who arrived in 1607 were male, but a number of women arrived the following year. Since JR1225B could have been buried at any point within the 20 years James Fort was used, the remains could have been either sex. In adult-sized skeletons, an individual's sex is determined based on variations in the pelvis. An adult female pelvis is shaped differently from a male's, allowing room for an infant to pass between a mother's pelvic bones during childbirth. Page 32. Also, the hip bones, which are a part of the pelvis, are shaped differently in women than in men. Although JR1225B wasn't an adult, the features of the skeleton's pelvis were distinctly male. Other skeletal evidence provided further support for this theory. A male's long bones are usually larger and more robust than a female's of a similar age. Men often have larger teeth than women, too. JR1225B's remains met these criteria. Perhaps most conclusive were features Ousley found on the skull. The back of a male's skull, where a muscle is attached during life, has a larger ridge than a female's skull. Males have a more prominent brow ridge, the bony part of the skull above the eyes, than females. The chin tends to be more squared in males, while a female's chin is rounded, with the center of the chin tending to come to a point. The ridge at the back of the Jamestown teen's skull, a slightly heavier brow ridge, and a squared chin were characteristic of a male skull. This evidence, along with that of the other bones, made Ousley feel confident in asserting that JR1225B is male. Where did you come from? Another step in unraveling the mystery of a set of human remains is to try to determine the individual's ancestry. All organisms, including humans, adapt to their environment in ways that make their survival easier. Parents pass along these adaptations, including physical traits and characteristics such as skin color or hair texture, to their offspring. While each person is unique, over many generations, some traits may start to occur in recognizable patterns. In the modern world, people from many geographical areas travel far and wide, building new cultures and starting families, sometimes with people whose ancestry differs from their own. In the colonial Chesapeake region, though, people came from three distinct ancestries: African, European, and Native American. Certain features of a person's skull can provide clues about which population a skeleton may have belonged to. This information can be critically important in helping us understand how people lived in the past. That said, forensic anthropologists always keep in mind that each person is an individual. A given population may include many variations in bone features, and circumstances such as diet and disease may also affect the appearance of bones. Thus, it's important not to rush to conclusion about any individual's ancestry. Page 34. When Owsley began his study of JR1225b's skull, he looked for specific characteristics in the nose, cheek, and jaws. For example, many, though not all, people from Africa and their descendants tend to have a wide nasal opening and a rounded forehead. The front of the jaw often protrudes farther forward than the chin. Europeans and their descendants usually have a narrow nasal opening and a narrow face. The front of the jaw is usually in line with the chin. Native Americans and their descendants generally have a flatter face than either of the other two groups, with cheekbones that project farther forward. The front teeth of Africans and Europeans usually close together with an overbite, meaning that the upper teeth are slightly in front of the lower teeth. People of Native American ancestry don't tend to have an overbite. When the mouth is closed, the upper and lower front teeth usually meet edge to edge. When slight differences in the shape of the bones that form the roof of the mouth can help identify whether colonial period remains are African, European, or Native American. Ultimately, it's a combination of observation, laboratory testing, and precise measurement that enables forensic anthropologists to decide upon the most likely ancestry of a particular set of remains. Even without all these tools, however, Owsley could see that JR1225b's skull features, the narrow nasal opening, the narrow face, and the shape of the bones of the roof of his mouth, were like those of English people of the 17th century. Using these criteria, Owsley determined that the teenager buried inside James Fort was European. Owsley concluded his initial examination of JR1225b by asking Hudgens and Schmidt to measure the full scale in the long bones of the legs. We measure bones in situ for many reasons. At Jamestown, I've got to measure in place, or I'm not going to get the measurement of the whole bone, Owsley explained. Poorly preserved bones, which are common at Jamestown due to the clay subsoil, often crumble as they are removed from the grave. The fragments may be reassembled in the laboratory, but they won't exactly replicate their appearance and size in the grave. Next, Owsley took a close look at the arrowhead Hudgens had spotted. It could have remained so close to the boy's femur throughout decomposition only if it had been deeply embedded in his thigh muscle. Although many more colonists died from starvation and disease, some colonists died from wounds received in skirmishes with Native Americans. Had the boy died as a result of such a wound? Owsley's opinion was that the boy wouldn't have died immediately of the wound. It was in a fleshy area of the leg where a major blood vessel wasn't likely to have been severed. However, infection was common in the colonial Chesapeake region due to the lack of medical knowledge about cleanliness and the care of wounds. If the boy's wound had become infected, harmful bacteria would have quickly spread throughout his body, resulting in blood poisoning. A fast-acting infection of this sort can kill a person in a matter of days and does not leave traces in the bones. Further analysis of the boy's bones in Owsley's laboratory would supply information about the boy's life and death, though whether it would solve this particular puzzle remained to be seen.